First is, huh, first is, first is you go backward. What is important and what is not important? First thing you should always know that you know that order now 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. Now, why does 3 have s, p, and d? Because of the magnetic quantum number. It is only possible in 3 that 3 will have spd, 2 will have only sp, and 1 will have only s. But whenever so the first, this is the principal shell one, then you have the subshell. This is the principal shell, principal orbit or shell or whatever. This is the subshell, and s only has one orbital, and p has three orbitals. So that is why it has got 6 electrons and this has got 2 electrons, because each orbital will have only 2 electrons. So if this has 3 orbitals, so it has 6 electrons. D has 5 orbitals, so it has 10 electrons maximum that is possible. So that is why he's showing you wherever SPD comes, they will only have, S will always have one subshell, one orbital, and 2 electrons. If it, whenever p comes, it will have 3 orbitals and 6 electrons. Wherever d will come, it will have 5 orbitals and 10 electrons. And wherever f will come, it will have 7 orbitals and 14 electrons. Together together spdf in 4 will add up to 32 maximum. Together spd, f is not allowed in 3, will have 2, 6 plus 10, 18 is. That's why there's configuration 2, 8, 18, and so on. But always remember, if the question is asking you, if the question is asking you number of occupied orbitals, first you will have to find the subshell or the type, and then you have to count how many does each, this has 3 in each p. So there are 3 p's here. There are 3 p's here. So that means each has got 3 orbitals. So total there are 3 into 3, 9 orbitals. So this is the answer. And S, how many S we have? We have 1, 2s, and we have 3s and 4s. We have S in 4 principal shells, 1s, 2, 2s, 2 and all that. And each has got only one orbital. So their total may 4 orbital, because 4s and each has one. So 4 orbitals. D occupied is only this 3D. 2 doesn't have D, 1 doesn't have D. So 3 has D, and there are 10 electrons, and D always have 5 orbitals, and all of them are occupied. So because there are 10 electrons. So you should know that so what is the difference between 1s2, the S of 1 and the S of 3? What's the difference? So no, when we have 1 S2, then we have 2 S2, then we have 2p6, we have 3 S2, we have 3p6. What's the difference between 1 and 2? 1 and 2 is there's a radius, the difference in the radii of these two. That means if this is the nucleus, 1s is closer and 2s is farther. Now if this is farther, the energy of this will be higher. So 1 is a smaller radius and 2 is a is a bigger radius and a higher energy. The more you get close to a nucleus, the lesser the energy. So the shell is, if it's close, if the 1s2 is closer to nucleus, so that means the electron energy is lesser. Energy of electrons is lesser than 2s2. Then what is the difference between 2s2 and 2p6? S has got a spherical shape, P has a dumbbell shape. What is this shape? This is the probability where you will find the electron. This is the volume where you will find the electron. Acha, then what's the difference between 1s2 and 3s2? Obviously, the S is spherical. Here also it is spherical, but 3s2 will be bigger than 1s2, 2s2. Okay? Because it's a higher energy state. So the S shapes will be same, but it will be a bigger radius. Understood? अच्छा चलो